before drives, and he wants to share his expertise for us. Roger, take it away.
There you go. Yeah, we've done a couple of these where we're using Studio 5000, but we were asked to actually use just CCW. It's a Connected Components Workbench software. If you're not familiar with it, it is we call it CCW. They're currently at version 13. And the very interesting about this, the standard version of the software, which everything I'm doing today, the standard will work. I happen to be running Workbench Developer, but everything I'm doing today is included in the standard version. And I point that out because the standard version is free. And that's really hard to say, Rockwell Automation and free in the same sentence, but nonetheless, this is, and it's an extremely powerful piece of software. That's why I was kind of glad to show it today. And to get it, you could literally either go to your favorite web search engine and just type in Rockwell CCW, and it'll take you to the link. You might have to register. They just want to know who's getting the software, but you might have to register. But once you do, then you could download it. I caution you, don't use your cell phone as a hotspot. It is about a 4.3 gig download because it has all the manuals for all the devices. It has all the information for all the devices. It does our drives, our PanelView components, our McClary 800s, our E300s, as well as some other products. So it is a very powerful tool, and hopefully by the end of the day or the next 30 minutes, you'll see that. So this is CCW. This is what it looks like when you fire it up. And just to kind of go over the start page, there's more than meets the eye here, because I did want to show you if you needed more information on the software. I mean, of course, now you've downloaded the software, so you've got it, but maybe you want to go check and see if there's a later version, or maybe you've got some questions about it. This is actually the software homepage. So from the start page, it takes me to Rockwell's homepage for the software. So just to get you more information. There's also training videos available. By clicking this link right here, it'll take you to the YouTube channel. And then you can see all the, if you want to know how to do something, I trust you, there's a YouTube video for it. Things like, Micro 800s and Modbus communications. The very bottom is when they're configure a motion axis for a Micro 800 controller. So there's a lot of wealth of information available to you on just those videos. And then even more important, I use a bunch and actually point my customers to, this one here is called sample codes. There are sample codes that have already been written for you, and they're free to download, and you can just search them. There's several of them, and what these are, they're typically going to be either a ladder program or a UDFB, user defined. You can see it right here, user defined function block that somebody has written to do a specific application or action, if you will. And you can see some of them right here, like a UDFB to let the Micro 800 control a Kinetix 3 or something like that. So there's also ones on here about Modbus communications on the drives. A lot of information there. A lot of people just kind of blow past this screen. Okay, on the left, you see I have a project. I could do a new, open existing, or what I'm going to do is discover. Okay. Now, if I knew of a project, knew of a project that I'd worked on before, like this one here, I actually created this morning, I could open it up and begin working on it or continue working on it. So let's just say I fired up my laptop and I'm now plugged into the drive. Let me kind of back up here and show you what we've got. This is what we're looking at today. It's kind of a busy demo box, but just kind of ignore everything. The motor there is in the bottom, the PowerFlex kind of diagonally going backwards. That's the motor we're going to be controlling. And our trusty drive is this right here, this PowerFlex 525 drive. So that's our demo box, and we'll be showing you the motor as we're auto tuning and such like that. That's our hardware design we'll be working with. So I need to go attach to that drive, and I'm going to click discover. Discover will go out and launch RS links for you, and in particular the RS Who browser. And if you've had your links already configured, you'll have these the drivers here. If not, you'll need to configure those, and it's a separate topic, but it's extremely easy to do. And you can see by my network, the only thing I have between me and the computer, whatever, is this drive. I did that on purpose. So we're going to select our 525 drive right there and click OK. and it literally goes out and interrogates the drive, uploads everything, and there we have our drive. So this is the start page, if you will, and I'm going to go over some of the items that are available to us here. So we've got the overview page, and we have device definitions. Now, it went out and told us that we have a 525 drive. The drive reported back I'm a single phase, 110 volt, 1 horsepower drive, and I'm firmware revision 5.001. And then device definitions on this side doesn't really show a whole lot. If it was on the Studio 5000 side, it would, but there's not a lot you need to change here. If I had any peripherals in my drive, say an encoder card or a dual port Ethernet card or some of those other card, it would actually show up right here. So I can actually do some configuration on those cards right there. But that's the device definition page. Not a lot going on, but still important. I'm going to come back to these guys right here after we're through starting the drive up, a compare and a data logger. It's just, very important. Oh yeah, I'm going to go over here right now and go ahead and add this to my project, because over here on the left, you see I have no devices. And so if I were to configure everything and just close out, I'd pretty well lose, what I'd gain as far as my project goes. So I'm going to add the project, and it's uploading it again. And then now I have a drive sitting over here, and I can have multiple drives. I can have a 525, a PowerFlex 753, a 755. I can have a Micro 800, a PanelView component. I have multiple devices over here. But we have our drive right here. Okay, and so now I'm going to drop down here into parameters. And now we are actually live and on connected with this this particular drive. And you can see we are, because there's our DC bus voltage sitting right there at 321 volts. We are actually looking at the parameters. So you could change parameters from this point. You could filter parameters. If you're looking for XL rate, you don't know the parameter number, you could just type in XL, and there's XL time 1. So it does help you filter. And if you want to look at other, I always like this guy right here, show non-defaults. And basically everything now that's got this funny color right here, this has been changed from factory defaults. So it just helps you in searching. If you didn't change the parameter, well, it's not in here. So, but these are all the parameters that have been changed from default. And I'll click back to show all. And then if I had multiple peripheral devices, say the dual port Ethernet or an encoder card, I could literally select these over here as ports. This 0 right here is a port. This goes along with our 753 and 755 drives. They actually have ports. Port 0 is the device itself. And excuse me, the other port or the devices and where they are. Faults and alarms, exactly what it sounds like. Okay, what are the last faults and alarms? This one is, I pretty well cleaned it up working here. So I've had 3 alarms or 3 faults. You can see I had a enable network loss. That's because I unplugged the Ethernet cable. And here, fault 48, parameters default. In other words, I reset these back to default. So these are the faults and parameters, if you will, that you could actually diagnose. If you didn't understand, say what that one was, that enable network loss, I could just click that ellipse button and then the blue question mark, and boom, it actually takes me into the manual. And now I can actually read up on, what happened and solutions, cycle power, check communication cable, check Ethernet IP setting, check external network status. So this is why this program is so big. It's got all these manuals for the products. So that's faults and alarms. Device info. If it was a later firmware version, it would literally give me the manufacturing date. I was online with a 753 yesterday that it actually gave me the manufacturer date. It gives me the serial number, the rev. This is so if we had a problem with the drive and it did fail, somebody within tech support or whatever might ask you for this information. You can go right to it, and it'll provide you for it, provide you with it. Okay, wizards. We're going to spend a little bit of time on these. There's something called a startup wizard that I use a lot, and it literally is just that. It does help you start up your application, and when you're through running the startup wizard, you have about probably 98+% of applications taken care of. So anyway, we're going to open up the start wizard right here. There's a couple other ones, step logic wizard and the setup wizard, if you will, here for doing position or velocity. We're not doing those, so we're just going to open up this one here and click the start. And now it's going out and grabbing the pages. And here's our page. And the thing I like about this is I kind of did this on purpose. We already have an error, and it's denoted by this little red exclamation point. Okay, and we'll look at that in just a second why that's occurring. But at least it tells you, hey, there's a problem. But we're live with this the device, and the reason I know that is because there's this green bar right here, and it's solid, so it tells me I am connected to the device. Here's the welcome page. It even gives me the revision of the wizard that I'm running. Okay, so click the next, and we're just going to go through it and just fill out the blanks. This is where I could, if I wanted to, reset factory defaults, and you have three options. And depending on which drive you're using, you have a different flavor of options. The first one is, of course, reset all settings to factory defaults, but retain the custom parameter groups. And then you can reset all factory defaults, including custom parameter groups or just the power parameters. That is, motor data, just your basic rudimentary parameters. So you could reset, and if I'm ever helping a customer and they're off in the weeds and we can't figure which direction's up, I'll typically encourage them to let's reset parameters. Or if you pull the drive out of spare stock and you don't really, it's out of the box, you don't know where it came from, it's a good idea to reset back to factory defaults. So once we've done that, we can select our language that the HIM will display and that we'll interact with. I know Texan pretty good. English is my second language, so I'll select English. And now I have a choice. Now we start getting into where we say the rubber meets the road. I need to select how am I going to start this drive, or how is this drive going to operate under motor controls? Volts per hertz, which is a very simplistic design, if you will, literally 7.46 for every hertz on a 480 volt motor. Not a lot of fancy. If I do select it, I'm able then to actually go down here and change some other settings as far as break frequencies and the like. I could put it in sensorless vector. I could put it in full flux vector. And notice here on our 525, we have actually now given you the ability to select a permanent magnet motor. And then that is telling you here, go in these parameters and make sure we select the proper, is it surface magnet? Is it internal magnets? What is it? By default, we leave it at sensorless vector. That's just by default, that works on almost every application. And what is my maximum voltage? Okay, in this case, it's 230 volt. Okay, so we leave that alone. Now, this next portion is extremely important for tuning. As you can say, tell, I've gone in here and made some settings, but because by default, if it's a 1 horsepower drive, the wizard is going to give you the default parameters for 1 horsepower motor, the amperage, everything. But in this case, I got a 230 volt motor. It's 60 hertz. It's 0.2 amps and 0.2 full load amps. It's a very, very small motor. And it's 4 pole. If you don't know, and some motors don't have the pole listed, and you can Google this, and it's just a real simple formula. If you don't know the poles, you can put a little math formula. Poles equals to a constant of 120 times the frequency divided by base speed. So in our case, we take 120, the constant, times frequency is 60, and we divide that by 1800, and we come up with actually 4.5. Well, there's no such thing as a 4.5 pole that I know of. So we know that's going to be a 4 pole motor. And that's important when we're doing the tuning aspect of the drive. In fact, it won't work if those aren't set correctly. And then our motor nameplate power and KW is 0.03. Like I said, it's a very small motor. Motor feedback type. If I was doing some sort of position control or following control, I had one drive following the other, I would put an encoder card in there, and I have to tell it what type of encoder card, I'm sorry, what kind of encoder there is. Is it a pulse train, single chain, quadrature? What is it? We can't do resolver, but we can do a lot of different encoders. And then once I select the encoder, how many pulses per revolution and that kind of stuff. So it's literally, you can see where it is. We're just filling in the blanks. Okay, stop mode. If I select stop mode of ramp and clear fault, which is typically where we do it. If we end up with DC bus over voltage and such, I have to go up here and tell it, how big is my dB resistor? Okay, and then I also have to go over here and select, say, DC break and clear fault. And then I also have to fill in the DC break level and time and some other information. But we don't have a DC break, so I'm still just going to put ramp clear fault. But you can see there again, all we're doing is simply answering questions. Okay, next. Now, this is the direction test. Say I'm actually connected to my motor and it's running 0 hertz. Now, you have to be careful with this because we are actually going to, let's say, rotate the motor. I'm going to put 5 hertz as a commanded speed and turn my camera back on just so you know. There is my motor. It is actually turning 5 hertz. And to me, it is turning in the correct rotation. So I would then say stop. And it asks me, is the direction of the motor rotation correct for the application? I would say yes. On this drive, if I said no, it simply tells you, hey, safely go swap the wiring of any 2 motor phases. On our 753s and PowerFlex 755s, the drive can swap the output leads internally. I caution people on doing that. I say the safer method, and it's just my opinion, safer method is then to go and change your output leads at the motor, not at the top of the drive. Go change it at the motor or the output of the drive. So in this case, I say yes. There you go. It gives you a little green check mark, makes you feel good. If I had an encoder and the motor were running, I would actually see a feedback right here. So that tells me my encoder is wired properly and the drive is seeing it. So we're already helping you with a little bit of troubleshooting. Okay, click next. Now we're going to auto tune this thing. Now this motor is so small that it's going to turn, but typically on static tune, it shouldn't turn. It literally just fluxes the motor up based on that motor data that you gave it. And so I'm going to click static tune and then quickly switch over to the picture. And so you can see that motor might bump a little bit because it's so small of a motor. It's really hard for us to get precise control. And so what we're doing now is doing a static tune. There's also a tune that's available called Calculate Tune, and it literally just takes the tuning parameter, I mean the motor parameters that you gave it, and it calculates the value. Okay, so now that one's turning, and like I said, it's such a small motor that it fluxed up enough to turn. But anyway, so now we have a test complete successful. Now to further tune it even further, we're going to do a rotate tune, and on rotate tune, yeah, the motor is going to rotate, and you'll see it'll do the same thing as a static tune. It'll take those parameters that it just learned, and now it fluxes the motor up. And you probably can't hear it, but the motor is fluxed up, meaning it's just magnified, and then we will rotate a couple times around, and then hopefully we'll actually pass this test successfully. Okay, there we're starting to rotate. And once it's going through its configuration, hopefully we get a green check mark and life is good. Now we're decelling. And if you lie to it on the motor data, okay, rotate tune error. That does happen on this one sometimes because it is such a small motor. And so anyway, please verify the motor data is correct. Of course, it auto-tuned perfectly the 3 times I did this morning, but for demo purposes, we know that's when it fails. But anyway, that's the rotate tune. Okay, so here is your ramp rates and speed limits. You literally can set the max frequency, and that's 60 hertz. I could crank that up to 70, 80, 90 hertz if I wanted to. And I could also set my my min frequency right there as well. Because if it were a pump, I don't want the pump to be able to go 0 hertz. I want it to go at least say 30 hertz so it can actually do some work. S-curve is just what it is. It's not a linear now. It's actually a percentage of the XL decel rate. And in certain applications, I've found that actually works smoother and better, if you will. I'm going to change these to 5 and 5, just to show you at the end what's going on. Now you notice if I clear that out, I instantly get an error right here that says only values from 0 to 600 are allowed. I have no value in there. Yes, I can put 0 as a decel if I wanted to. Better have a dB break in there though. But anyway, there's my 5-second XL and decel time. Enable reverse operation. If this is say a horizontal pump or some other pump that can never, ever go reverse, I would uncheck that, and now enable reverse operation is removed. It cannot reverse. I'm going to leave it enabled. Okay, now we get to our screen where we have our error. It has a flashing little box right there that says, check other speed references. No 2 speed references can be the same value. Well, I've got Ethernet IP there, and I have Ethernet IP there. So I'm going to change this one to our drive pot because I do want to be able to control it. But let me show you this under speed reference 2. If I selected, let's say 0 to 10 volt like I have here, it actually shows you on this particular drive in Wizard, it shows you where to land the wires. Plus wire on 13, common on 14. And I can actually scale 0 to 100% to 30 to 60 hertz. I can actually scale it right here. If I had an analog pot wired in, I would actually see a value right there. So now it's telling me, yep, it's wired. I see it, and this is the value I see. So it really helps, head off a bunch of troubleshooting issues after startup. Okay, so we're all good there now. We got rid of our exclamation point. And this is where I can set the IP address of my drive. I kind of want to keep talking to it, so I'm going to leave the IP settings exactly as they are. Digital inputs, okay. Stop mode is a ramp clear fault. Start source, I'm going to change from Ethernet IP to the keypad just because I'm not plugged into my PLC. And start source number 2 and 3. But look down here. This is a stop button. It's fixed, hard coded. You can't do anything about it. In fact, even if you don't use it, you still have to make a jumper from 1 to 4 in order for this drive to actually work. But if I go a 2-wire forward, it actually shows me, okay, bring 24 volts into terminal 2. So it actually shows you where to put and land your wires. So those are digital inputs. Let's go digital outputs. My relay output normally open, and I have a relay output normally closed. When do I want this to close? When I'm at speed, motor running. You've got a whole host of options that then would allow this contact to enunciate back to a SCADA system as a digital hard input. Some people do require that, and I have a normally closed relay as well. And then I actually have opto outputs, and I have analog outputs. You can actually, it tells you landed on 16 in common. And now this one's going to go from 0 to 10 volts based on output frequency. I can make it, output current. I can make it whatever I wanted to of these selections right here. Okay. The next screen is kind of cool because now it tells me if I click finish, these values are going to change. Parameter 439. Let me back up because I did forget one thing I do want to point out. Let's go speed control and drive pod. Yeah, it tells you parameter 47. If you just hover your cursor over that, it tells you which parameter. So you can either do it here or literally go to the drive itself. I forgot to point that out. So these are the parameters we're going to change. I do want to change digital input start source, and I do want to change speed control. And I changed S curve and decel and XL time. Okay, so I'm going to click finish. And now we're back at the drive. So I want to look at this overview. I was talking about this data logger. I tell you right now, we're going to go just a few minutes over, folks. I do apologize, but let me just quickly show you this. Here's a data logger where I can actually log data to a CSV file that I can then send to a colleague or for future reference. And let's just say I want to look at output frequency, output current, and output voltage. I'm just picking 3 just for the sake of time. Now I go up here and I say, okay, what is my size of my capture? Hours, minutes, and seconds. Let's make our job a little easier. And I'm gonna put in 30 seconds, and I want to capture every 5 seconds. Okay, that's set up. I click next. It asks me, where do I want to save the file to? I've already created one here. I'm going to overwrite it. It's going to say, do you want to overwrite it? I click yes. As soon as I do, there it clicks. So I'm actually going to start our drive. Now I'm changing things. My output is frequency is going up. My output voltage, output current. See, my hertz is now at 60 hertz. I can slow it back down. I mean, these are just data logs that you might want to look at for troubleshooting. I'm gonna go ahead and click finish for the sake of time. It's to stop logging. And at this point, I click OK. And I go back to my file. I open it up, and there all that information sits with a time stamp and the information. I mean, the date stamp and time. It even breaks it down into the milliseconds, okay? So you get pretty granular with this guy. Okay, that is the data logger. The compare is just what you would think it is. I'm going to compare this online project to a file. Okay, now let's do the default. It's actually quicker for us. Compare. Let's go compare to default. So now it's comparing my drive to what default is. You can see project is 0.2 amps, default's 4.8 amps. I use it a lot of times when I have a customer has two identical systems. They say they're identical, and they say this one's working, this one's not. Of course, I'll always go, then they're not identical. And to prove it, I actually go online with one, and then I go and compare it to a device. Okay, I compare it to a device. So I compare it to my device and the other device, and it will show us what's the problem, what's different, and then maybe we can make a decision. That's the compare. We can also do a trend. I click trends. I'm gonna click on the plus sign here to add a trend. Okay, now it's gonna look real similar to the data logger. I click the plus sign. I want to look at my PowerFlex 525, and I want to look at parameters, and I want to look at the basic display. Once again, let's grab output frequency. Let's grab output current and output voltage, and I click add, and then click OK. And now it says I have to push the plus sign. My drive is running, and there you see my actual graph, if you will, based on the parameters here at the top: output frequency, output current, and output voltage. Okay, if I click stop, because I said, okay, I think I see a problem right here, it will give me my output frequency was 4.74 hertz, output current was 0.22, output voltage is 45.6. Doesn't mean much right now, but if you were charting parameters that were giving you problems, that might very well get you through. So that was a whirlwind tour of Connected Components Workbench software, but you can see it's extremely powerful and effective. And did I mention also it's free? Oh, also this trending, I can export it to a CSV file. I can print it, and I can actually go in and change some of how our pins are displayed on the screen. I can stack them. Actually, that's done down here. I can actually stack them. I'm sorry, overlay. And now there is one group, so they're more together, if you will. So, but anyway, that's what I've got as far as CCW. Anybody on the panel I got anything to add, or any questions came in we need to answer?
No questions at the moment, Roger. Very good demonstration. We'll let everybody take a moment. You can chat or type a Q&A, or raise your hand and we can unmute your line if you don't ask it live.
Yeah, and for sure, if questions come up, be sure and get with your specialists. They can definitely get with me, or they very probably already know the answer, and we can definitely help you out. I just want to show you how powerful this, it almost hurts me to say this free piece of software actually is.
It should be noted that the CCW software was put in drives. Can configure the soft starts too, right, Roger, and a few other products. It's a versatile tool. It was a Micro 800 family, PanelView 800 family, so it's a versatile tool to have. All right, no questions, so we'll wrap up, I suppose. Roger, we appreciate you taking the time to demonstrate this, and we everyone's time to join this morning.
Fantastic, guys. Thank you so much. You guys have a safe day.
All right, thank you.